Hello everyone, thank you for joining me. My name is Dmitry Vinnik. I'm a senior software engineer at Salesforce, Canada. And so my talk is aspect-oriented programming, or hidden toolkit that you already know but don't use as much. And I'll start my talk, as I always do, with a quick outline of what we will cover. So I'll begin with the quick overview and the explanation of what is the purpose of aspect-oriented programming that's been mentioned, I think in this track particularly, at least in 3 presentations or so. Then I will move on to the more advanced applications of aspect-oriented programming using AspectJ. And then I'll transition to Spring usage of aspect-oriented programming. And I'll try to wrap it all up with what the Java agents are that probably other people mentioned. I'll do it really briefly, and then I'll focus on other implementations that's available on the market as open source and enterprise solutions. So I'd like to first explain why I decided to give this talk. As many of you encountered some everyday problems that all developers face at some point. I was thinking how long this operation takes, what my code coverage is, and can I actually make my hot swap faster and better? Like, can I have a productivity boost from it? Or, it's simple questions like, do I want to log it in every single operation? So those kind of questions always come up in your mind while you're working on some feature. And while I was searching for a solution, I found aspect-oriented programming. And then I realized that I actually knew it from before, but I never realized what it was. And that's actually the problem. It's what I'm actually targeting and aiming for in this talk, is to explain that you all have a skills and you probably used it before, but I hope if I highlight more advanced utilization of this paradigm, you'll be able to expand its usage in your code base. So I'll begin with the overview of what aspect-oriented programming is and try to highlight the main questions it tries to answer. So, I put some pseudocode in here, and if you were to even search in Wikipedia, the first sentence you would see as a definition of aspect-oriented programming that it's a cross-cutting concern paradigm. It sounds fancy, but if you look from, to explain it a bit more, I actually like to look back at what object-oriented programming is. So if you use Java, you always try to think of separation of concern, and have single class or single method to have one specific goal in mind. That's what it means by single concern. With aspect-oriented programming, you take it a bit further. So as you look at this pseudocode on the left, the perform action is the main concern of this function. It's what it's for. But if you look at the beginning and the end, there is a start timer and stop timer. So basically what developer had in mind is to be able to somehow collect the metrics of how long this operation takes. And as you see from these generic timers operations, this developer most likely will do it all over the place the same fashion. There's not going to be much variation. And so these timers, this is what aspect-orienting is all about. It's basically using this different concern of timing the operation and inserts it into the concern of this function, which is perform action. So this is what it's all about. It's basically injecting its own concern into the main production code. And as I highlighted in the very beginning, the main questions it tries to answer that you might have in mind is, what is my code coverage? Is my JVM or application even running? And do I have to restart my whole app for this single signature name? And again, how long does this process actually take? These kind of simple questions. And this specific slide actually targets, it's evidence that you already know aspect-oriented programming and use at some point. I'm pretty certain that all of you done some variation of this. Apart from all this code base, the main idea here is you basically get current time, then you trigger some operation, which in this case execute long process, and then you get the time again. And by having the difference of it, it actually will produce you output as the time that this process took. So basically what it means is just by using the default Java package system, the default Java class, sorry, and by retrieving the current timestamp and the current timestamp after the operation, as simple as it looks, this is what aspect-oriented programming is at its simplest form. And as I mentioned, you definitely use it at some point. And as we all understood now that it's actually a hidden toolkit that you're aware of but don't use as much, I'd like to explain what the advanced aspect-oriented programming is all about and how it can be expanded further in your code base by using one of the main aspect-oriented programming languages in Java called AspectJ. So it's basically the main way developers actually use it outside of a Spring is to define a special file with the keyword aspect. So it's not an extension of Java, it's a different extension, and to define it you always begin with the highlighting this is actually an aspect. The second part of any aspect is to have a point cut. Point cut is nothing more than the binding to the operation you're going to target during your aspect. And the last part is, of course, to have some logic around it. It's your advices. And now just to go step by step on those main parts of an aspect. So the point cuts. The point cut contains next main sections. So it's a definition. You have to define your point cut. So you'll begin by using the keyword point cut. Then you have some descriptive name. The next part is, of course, to have a type. Basically, the second part after the column is what defines the actual binding. Everything before just defines availability of this point cut. So the execution in this case is a type of a binding that I'll cover in the next slide. And the last part of any point cut is to have an expression you're looking for. In terms of point cuts and their types, there are, you can summarize them in three main types. The first one is methods and constructors binding. So basically, the call and execution types are similar. I'm not going to go into details unless there's a question afterwards. But basically, it's all about binding to the operation of some sort. The fields type point cuts, it's as simple as set and get. So consider some use case of, you want to enforce immutability of your POJOs that you unfortunately have a setters on them, like a date in the standard Java packages. If someone actually set the date instead of using defensive copying, you want to give an advice maybe and make it part of your process. In terms of a last type here is the exception handling, which can be quite neat. In this particular case, you only specify instance of for a class that you're actually looking for in your aspect. So imagine a case where you have a security exception and you want to generically notify your DevOps or someone who's actually on a support side through the PagerDuty or whatever alerting system you use. And everything, the only thing you need to do is to define it once in your aspect, be bind to the security exception and notify right away. This is one of the use cases you can consider. In terms of the expressions, they can be very flexible. It can go from affect all the operations to the specific operations of a certain action, like you see here in the actions that execute long operation. So basically how it looks is you can define the visibility and, for example, target all public functions, all public static, or as I mentioned, some specific methods. The type patterns I already highlighted in the handler type. It's basically you specifying a class of some sort that you want to generically handle. And the last type is the point cut and point cut combination within the point cut. So again, we are talking right now about expressions within the point cut. And so you can have the inline definition, like cflow is actually different type of point cut. But imagine that call is different point cut you actually target inside. It's slightly over complex to some extent. This is why the best practice is never to do inline definition of a point cuts and always define them separately as the best practice. At the same time, you can also combine them using this generic Boolean algebra. And as I mentioned, just when you work with aspect-oriented programming, all the software engineering principle, like keys, keep it simple, still applied. So use those when you make a decision how to proceed. In terms of advices where the actual logic stored for handling a certain operation. of course. No. Sorry. Yeah, so for the advices, the main anatomy of advice, are you kidding me? Okay. Okay. Let's just remove this thing and can I proceed? Okay, I can proceed. Okay. Anyways, there was an update recently, so in terms of the anatomy of advice, you have advice type, before or after in this case, the point cut binding. So the point cuts you just defined in the previous slides, you bind your logic to. And the last part is actually one of the most important, is the logic you're going to attach to the binding. So let's go step by step. All right, I'm going to use this. So let's start with the types of advices. So again, there is always before and after. That's quite fairly simple, right? So in this case, it's referencing back the timer thing that you can, before you can start the timer, and after you can actually handle it somehow, you know, stop the timer and log it or do something with it. Another type is much more complex, is around advice. Technically speaking, it's not actually advice to use it as much. You know, use your judgment, but it's a bit overly complex and you can always just get away with using after and before. The reason why I say that is the idea of around is it's a combination of the above. So what it does is actually you can do something before you have a process, then you actually trigger the main process you were bound to, and then you have the after clause after the process finishes. So basically now here in aspect-oriented programming in this aspect, you actually have a control over the actual process you are bound to. So it's just generally you going beyond what you actually were targeting. In terms of a binding for the advices, there are a variety of ways to do it. The simplest one, of course, is to use a single point cut that we defined earlier, like, you know, time action. It's only targeting certain like public calls. The joint point cuts, again, Boolean algebra to the rescue. You can use anything, any operands, and or not. Then you also can use inline point cuts, which you, again, might want to avoid. And the last one that I'm not actually going to cover as much because it's a part of inner types and aspects, but it's parameterized point cut where you can actually pass a certain argument. So now you think that, oh yeah, it's so simple, you know, I define the binding, define the logic, and I'm good to go. Technically, yes, but there are a few things you need to consider and understand there is a lot to learn. And so some of that additional information is the idea of generics and declarations. So it's one of those advanced topics and bindings you can consider. One of them is the using the generics, as I mentioned. So in your signature in this case, you can use whatever you want. I mean, not just be bound to double, but support it similarly to what your production code looks like. It kind of introduces the maintenance hell, I would say, so don't try to match it too much, but be considerate when you're writing the code. You can also use abstract aspects, you know. It's very similar to Java in regards to the inheritance, so it's in single inheritance only, and you can have, you know, abstract aspects, point cuts, advices, whatever you feel like. Declaring parents is slightly more complicated. Again, it's part of an inner type thing and aspects. I'm not going to cover that as much, but the one I want to mention for sure is declare soft. That's actually quite neat. So what it actually does, imagine a case where you generally have an exception of some sort, so custom security exception. And the way you usually handle it in a production code, you always have a try catch, you log it, and then you proceed with the exception. And think that you were to do it everywhere in your production code. So instead of doing that, what you could do is just declare soft, and then bind certain action, in this case, try catch logging certain way, and it will affect your production code as well. Meaning that it won't get rid of the exception, especially if it's a compile time exception, but it will help you with handling it in a generic way. So it's might be useful for you. And then the last part that it's actually quite important is how you even run it. Again, it's a different format from Java, so to actually compile it to the binaries, you need to use a different compiler that's managed by Eclipse Foundation, so you can trust it. It's a HJS compiler. After you switch the compilers, you just run your program and you're good to go. Another thing that's actually satisfies me a lot about AspectJ is the annotation development style. You can use annotations instead of using completely different keywords which you are not familiar with. And again, you always have to think about maintainability. You know, a new person comes in and they think, what the heck is that point cut keyword? I never heard of it. So instead you use annotations, and the new person never concerned of what the heck point cut is. So you have everything. You have aspects to define your aspect class, so you use a regular Java here. You have a point cuts with the same thing as type and signature. And of course, never forget advices. So you have a before, after. By the way, notice that here we have a return type all the time. It's kind of different from what we had with aspects where we were able to omit that part. Here you actually have to because it's a regular Java. The around one is slightly more complicated, but it's actually a better example of real around. The thing about around is it accepts that argument, that's the real process you're controlling, and established access in this case is before before advice. Then you trigger the process using that proceed, and you do something after that. And this is what the around is all about. So you can see why it's dangerous. Now I'll try to switch to another mainstream application of aspect-oriented programming. It's Spring. So I'll begin with a quick overview. And as always, you start with a Spring, its configuration, which might be quite difficult for the newbies. So, you know, there are always two options, right? You can use directly use Java. So the only thing you have to specify is configuration annotation, and the one you have to do either way is the enable AspectJ auto proxy. And then you just define your aspects of its regular bean. Different approach is to use XML or a schema style definition where you have the same line for defining the proxy as you see here in the AOP tag, and then you define your bean. The next part of the Spring AOP, of course, is the thing that I think they did correctly, is to support AspectJ, the native AspectJ. So if you had already framework set up for it, you don't have to switch as much. There are some limitations I'm going to highlight, but technically speaking, it's almost one-to-one. So again, everything we just learned in the previous slides about AspectJ, the annotation-based though, specific annotations, or as they call it, AspectJ 5. I think it's kind of connected to Java 5 that started supporting annotations, but that's aside. It supports AspectJ. Again, there is always the Spring way to do things, schema-based aspects. So here again, you have your aspect using the AOP aspect tags. You have your point cuts. Similar way, you name them through mentioning the ID. You specify in the type, and you put some binding into it, the signature. Then you also have your advices before, after, and around. The same similar way you would do with Java. But there is always some caveat here, right? When you're comparing to and thinking what to use, it might be slightly debatable, but some points are quite obvious for all of us. So if you use the AspectJ annotations, basically the plain Java in this case, it's a drive-by design. You can use inheritance same way you would use Java. But with Spring XML, it's slightly, killing the idea of separation of concern, because all your aspects, point cuts, everything gonna be just dumped in a single file, one after another. So again, you can't use your experience as much as a Java developer with aspects. And you can probably see from the number of negative and positive what I prefer. I'm slightly biased. In terms of what one approach has that other doesn't, is the point cut combination. That's only available in AspectJ's implementation. In XMLs, you cannot do that. You will have to actually manually define each and every single expression for each advice. Also, the cool thing about AspectJ is that it's reusable outside of Spring, so I don't think you would ever migrate from the Spring back to AspectJ, but you can actually go to the reverse. If your framework before had quite a few aspects defined, you can just transition to Spring seamlessly. For XML, this part is debatable, but they say it's better for the enterprise services. People like configs for enterprise. But again, as I mentioned, debatable. Visibility-wise, XMLs are always better. You don't have to actually step through the code. It's all in one file. So, no separation of concern, but at least visibility gets increased drastically. Yeah, that's basically the small comparison of two. But some limitations the Spring still has, just by definition of how it works. So again, it doesn't have a field level point cuts that you can define in AspectJ, a native one, which kind of obvious because it still uses Spring under the hood, right? And this actually highlights a second point where it has a limited support of objects that are not actually managed by Spring. So if you have beans that you don't actually inject and you're trying to connect them to your aspects, you're going to have some trouble there. And as a result, if you're mainly focusing the injected beans, the setters and getters are useless for the advices. And again, another thing, it doesn't support all the point cuts like a handler, which can be quite useful as I highlighted, and it doesn't support the call. But it still supports expression, so we're quite good there. Something that other speakers highlighted before, the Java agents, I'm not going to go into too much details. I'll just try to highlight the reason and the reason it's actually aspect-oriented to begin with. So again, probably people before me showed if you were to create create a Java agent, you will define the pre-main function with certain arguments that pass by default. You will have the main logic in some sort of implementation of class file transformer, and then you just compile your Java agent and run as the argument when you start your JVM in your main app. To highlight, this example, it might be quite large, but overall what it does, it just processes your binaries through, and you can do whatever you want with it. But the idea is still aspect-oriented here. It's cross-cutting concerns, because the binaries is where the main concern is. Whoever was writing the source code for it had some idea in mind, and this is how they created those classes, and they just going through this funnel. And whatever you do with the stream is up to you, but it's still cross-cutting because you append something to it. In this case, it's fairly simple. You take binaries, I decompile it, back up it, return the stream. It's just for the demo purposes. Not much of a sense, actually. But yeah, this is what the Java agents are all about from just a bird's eye view. So I kind of covered this mainstream advanced usages of aspect-oriented programming, and now I'd like to go a bit further and show some implementations of it on the market. And hopefully it will at least inspire you to see that there is actual need for them. The enterprise solutions are highly valuable for productivity reasons, and some of the vendors are quite profitable these days. Just a thing to mention, but in my presentation I only cover an open source for some reasons, but the main examples here will be open sourcing. So there are certain types of AOP implementations out there. The first one is, of course, the code coverage. Basically, the questions we had from the start is what I'm going to go through here. So the code coverage with examples of JaCoCo or Clover, benchmarks, profilers, another usage of aspect-oriented programming. I'll talk about JMH as an example, and AppDynamics is the enterprise solution. There are improved compilation Java agents such as HotSwap agent or JRebel that people talked about in the previous talks, and of course application monitoring of some sort. I only found kind of a simple one, the enterprise Java agent, but again there are a lot more. You can write your own, I would say. So let's begin with the code coverage implementation. JaCoCo stands for Java Code Coverage, so there is quite a simple acronym. What I'm trying to show here is the data it gives you. So JaCoCo is nothing more than the Java agent you pass to your JVM. And as a result, after it instruments your code, it produces quite nice report, I'd say. So it gives you all the metrics summarized per package, per class, and then you can go into the class directly and see line by line how it was hit by your test, which usually is the case, or by production code if you want to see what kind of cases your customers do going through. In this case, green is what was hit, yellow was where the condition is, and the red what was not actually tested for. Imagining this is a test. And so it actually can help you writing the test plan because it gives a very good overview of what conditions you have to begin with and what's covered. But thinking about why even using JaCoCo it's a Java agent. I like them. I mean, they don't require any setup. They exist outside of your main application. You don't have to control them as much. They handle their stuff on their own, basically. It produces the detailed report I just showed. It highlights the coverage down to the line. And it also supports instrumentation on running or pre-executed code. What it actually means, I'll explain in this slide by highlighting how the code coverage or any Java agent that I'm going to go through in the next slides actually work in the enterprise level as well. So basically, all the classes are instrumented on the fly by Java agent, considering using that approach. It performs in-memory preprocessing of all files. It uses that widely used instrumentation package that became available in Java 1.5. And then if the code was ever hit, the code that you instrumented, it will dump the data of that hit into the certain specific format file, .exec, and after you're done, it will process it into nice HTML reports that you've seen in the previous slides. That's basically the main idea. You funnel through, you instrument your code, and then you do whatever you want with it. Another implementation of AOP is the benchmarks. And I believe the previous speaker also spoke about benchmarks of their own. This one is a Java microbench harness that's supported by Oracle. I mean, it's created by Oracle to begin with. There is quite a few years ago, and I would say it's quite handy. So basically, what it does is by using simple annotations to the very least, you can write your own benchmarks or profilers to actually test the performance of your operations. And again, that benchmark you run outside of a core application in its simplest form, but the idea is that it has its own runner that it funnels through your operations, and again has that cross-cutting concern of defining time before and after, looping it through a couple of iterations, as you see in the output on the right, record separations, etc. This is how the benchmarks work here. Some of the, why I actually like JMH, even though I haven't used it as much, but among the other benchmarks. And because it's, they say writing benchmark is very hard to begin with. But the thing about JMH, they claim at least, they're pretty good in terms of testing processes individually. Because the problem with any benchmark is that when you test them outside of integrated system, the data might be unreliable in regards that when you actually have a full system, performance is much worse or maybe even better, but completely different from what you measured. When you use JMH, you have more control over environment in terms of you can actually create additional CPU usage and, etc. You can basically go wild with it. It's supported by Oracle, as I mentioned. Why it's good is because it means they won't get rid of it for a while and there will be a constant support of it. And it's highly customizable, Still, by using annotations to the very least, you can specify what kind of output and what units you'll get. You can specify a mode, how to actually run the benchmark without having understanding of the entire benchmark application. So basically, this is what the benchmarks are all about in AOP. Another, actual last implementation I'll cover is the improved compilation that were talked about at this conference quite a bit. So I'd like to highlight what the Java hot-swap is for those who are unaware. It's basically, it handles the recompilation of Java files to the very least. It's very simplified, but that's the idea. If you change the implementation of your method while the app is running, and the whole restart and recompilation and rebuilding will take a while, what you do, you just, you in your IDE, you just click recompile. And it would actually, you don't have to restart JVM, and it would replace the implementation with whatever your changes were. But it's not perfect. It doesn't handle certain scenarios such as, renaming, adding signature of a method, changing static, non-static fields, updating enums, and even hierarchy for that sake. If you're working on an enterprise level application, it actually matters a lot, that you don't have to restart your app. As the previous speakers, couple speakers before spoke, that some apps might require like half an hour from the speaker experience. And it might be, well, it's basically a productivity killer. And so this is where those AOP-based Java agents come into play. The hot-swap agent that I'm mentioning here is still in beta, but the idea is simple. Is that it's a Java agent that you pass as an argument, and it basically helps you to handle those imperfections by, again, using instrumentation and most likely similar to what JRebel does with their implementation of having a proxy on top of a regular class. But the idea is that it's basically handling those imperfections and gives you basically this productivity booster. As I mentioned, in enterprise, it's crucial for you. There is no setup required because it's a Java agent to begin with. And again, you have some sort of, more control over JVM you're working with. Not much, but still at least it gives you the idea you have a control. And I would say it has a good logging overall, quite verbose. It tells you what was recompiled and if it even recompiled. So you don't have to guess, oh, is my changes in yet? And there are basically a couple of other solutions out there. Again, some are enterprise, not everything is open source. And as I mentioned, the highly profitable AppDynamics alone, that was, I believe, acquired by Cisco recently. They are really good. JEEConf is open source, again, I think it's made by Oracle as well. There are some profilers out there that use the same paradigm of aspect-oriented programming, and JRebel, that's enterprise improvement of a compilation. So that basically concludes the main talk, and now I'll move into the Q&A. But the thing I'd like to highlight here, as overall summary, is that try to explain you first that it's a hidden toolkit that you all have, and you probably used it before. Then I move to the more advanced implementations and how you can improve your current code base, maybe move something to the more dry design of using AspectJ. Or if you're using Spring, all it takes is just include another dependency to your Maven or Gradle project, and then just get the benefit of it. But at the same time as anything, it always has some danger of going overboard with it. Again, as I mentioned before, maintenance can become a problem. And the support by IDEs, by development environment, is also an issue which you have to attend to. Even though IntelliJ, for example, has a nice plugin that can inspect your code for aspects and advices, point cuts, it's not perfect because the usage of aspect-oriented is not that high, as high as we would imagine. But at the same time, you always have to keep that in mind when you're writing something. Don't go too overboard with a new thing, even though that's not new, but it might be new for you and for your company. But yeah, use your judgment. We're all developers. So yeah, thank you guys. Thank you for listening. Oh, there's a question.
Thanks for your speech. And I'd like to ask you about advice around advice. Each advice you show, like before, after advices, they did not have any return type, return object, but advice around had one. And where this object actually is considered to go? Who is the consumer of it?
So it really depends. I mean, you can actually have a return type even in the regular after and before. It just, when you come to the around advices, it's considered more complex and part of an inner aspects, inner type aspects. And when you actually return it, the thing about it is, though, I believe the main idea, if it returns it to the pool, I would imagine, it's basically, it's almost you controlling a thread at that point. It just returns it back. So you process it and you return it back. Similarly, what you've seen with the Java agent, where it's nothing more than a funnel. So it gets something, you might want to modify it. Let's say it was returning your type, that the process that you were consuming and bound to, if it was returning your string, you want to pass a different string, or you want to update one of the attributes on that object. And then you return it back to the pool. And whoever called it, let's say that operation, get name of a dog. You were to bind to that point cut, then in a round you were to control it, modify it, and instead of, I don't know, Jack, you were to return Bobby, you can also do that. But this basically gives you control over a result of that call as well. So you don't just have a regular before and after advices, you also have a control of what it returns and what it does with the result. But again, this is why it's dangerous to use as much, because you basically step in a different ground of being involved in what production code does, and that's usually not a great idea with aspects.
Okay, if there's no more questions, we can go to on third floor and continue on track A. There will be whiskey party. So, yep, that's it.
Thank you, everyone.